a look at flowchart first. Okay, so it is recording right now. It is recording. So if we could get through this part quickly. All right. So I am looking at, for number 1, and I highly, highly recommend when you're doing these that you do it in this order. First, you read, given angle F is congruent to angle I, and FE is congruent to IH, and we're going to prove the triangles are congruent. So I read what the problem's stating first, like a word problem. Now I'm going to mark it. Angle F is congruent to angle I. I believe that I have mismarked this as H. Angle F is congruent to angle I. FE is congruent to IH. Then I look at the picture. What else is congruent? FGE is congruent to IGH by vertical angles. So then I know these triangles are congruent by angle, angle, side.
Side angle,
Yeah. Okay. So I have F and I are congruent, given. I have vertical angles, and I have my other given. FE is congruent to IH. So since I have these three things, it is congruent by angle, angle, side. Number 2. T is the midpoint of AB. Right, but I did not record it, so I'm just going to read it, and I'll go quickly. Okay, given T is the midpoint of AB, and BTO, is congruent to ATO, I want to prove the triangles are congruent. So I know that if it's in the midpoint, both sides of the midpoint are congruent. I marked the angles are congruent, and I know OT is congruent to OT by reflexive, so I've got side, angle, and side. So I write down A is my given, B is my definition of a midpoint, C is my angles are congruent by given, D is OT is congruent to OT by reflexive, and E is congruent by side, angle, side. Okay. Number 3. MS bisects AME. Well, I know bisects means it cuts it in half, so both sides of my angle are congruent. AM is congruent to EM, and that's part of my given. And then I look at it, and I'm like, okay, MS has to be congruent to MS by reflexive. So I've got my given. AM is congruent to EM. I've got MS bisects AME given. I know that MS is congruent to MS by reflexive. Since it bisects, I know both sides of my angle are congruent by definition of a bisect. This is what that's saying. And then the two triangles are congruent by side, angle, and side. Yes, Lorenzo?
On D it says AMS.
D says AMS is congruent to EMS. AMS is congruent to EMS. I want the M's to be in the middle. Okay. No, because I don't have this third side down here at the bottom. I don't know those are congruent. Okay, number 4 was probably the most confusing. We haven't done a lot with the parallel lines, so let's go over them. Okay, AE is parallel to DC. I like to draw an arrow to show that they're parallel, so I remember. B is the mid-segment of CE, so I know both sides of the midpoint have to be congruent to each other. Well, then I can also see vertical angles. Remember, when we're dealing with parallel lines, we get alternate interior angles are congruent. Okay. So now let's go through the proof part. We're given that B is the midpoint of CE. That means BC is congruent to BE by definition of a midpoint. I'm given that AE and CD are parallel, so I can say angle A, B, angle BAE is congruent to angle BDC by alternate interior angles. I can say angle ABE is congruent to angle DBC by vertical angles. That's what VA stands for. Therefore, it's congruent by angle, angle, side. I could have said that angle AEB was congruent to angle DCB This is an alternative. You don't have to have both of these. This is an alternative. And then it would be congruent by angle, side, angle. So this is an alternative. If you have that, you're still right. Yes, right.
So if you use the bottom one on E, then you have, it's area, no, angle, side, angle.
Yeah. Any other questions about the flow chart before we move to fill in the blank? Okay, let's look at fill in the blank. Now, I don't usually record all the homework like this, but because it's proofs, I want you to have this reference in case you get stuck on stuff like this, okay? Especially when we're going over, when you're preparing for the next quiz. All right, so the first thing you do is read. BC is congruent to DC. I put my mark. AC is congruent to EC. I put my marks. I want to prove the triangles are congruent. Are there anything else from this picture that is congruent? Vertical angles. So, I write down what my givens were. BC is congruent to DC, and AC is congruent to EC. Given. I say BCA is congruent to DCE by vertical angles. And then I have side, angle, side. Showing my triangles are congruent to each other. Any questions about number 1? We did number 2 together, but I am going to go through it quickly, so we got it. JK and LK are congruent, I mark it. JM and ML are congruent, so I mark it. KM is congruent by reflexive, so I write down my given. KM is congruent by KM by reflexive, and they are congruent by side, side, side. Number 3. I and G are congruent to each other. FH bisects angle GFI. So both sides of that are congruent. Both angles are congruent because it bisects. And FH is congruent by reflexive. So I have angle, angle, side. Now I fill out my proof part. Write down my given. These two angles are congruent by the definition of a bisector. FH is congruent to FH by reflexive, and the triangles are congruent by angle, angle, side. Any questions about number 3 that you don't understand? Because it says bisector up here. That is the only reason. Midpoint is usually a midpoint of a line, where bisects can be an angle or a side. Everybody ready for number 4?
Yeah.
Okay, number 4. N and Q are both right angles. NO and PQ are congruent. PO is congruent to PO by what? Reflexive. So, why are these two triangles congruent to each other? They have the hypotenuse and a leg and a right triangle. I think the hypotenuse leg is the hardest one to remember. Because you look at it and you're like, oh, it's side-side angle. Remember, side-side angle doesn't exist. But if it's a right triangle, you can use hypotenuse leg. All right. We've got, number 1 is given. Number 2 is if they are right angles, they have to be right triangles by definition of a right triangle. OP is congruent by OP by reflexive. We still have our other given part, and O is congruent to PQ by given. So they are congruent by hypotenuse leg. Any questions about number 4 before we move on to number 5? Okay. Number 5. Okay, this is with parallel lines again. I feel like a lot of people are getting these mixed up. I mark that they're parallel by drawing arrows. So, ST, I put 1 arrow, is congruent to RU, 1 arrow. SR, 2 arrows, is congruent to TU, 2 arrows. Okay, so I want to prove the triangles are congruent to each other. When I'm dealing with parallel lines, what do I usually deal with? Alternate interior angles. So these angles are congruent, and these angles are congruent. And RT is congruent to RT by reflexive. So we have angle, side, and angle. So number 1, we have the given. Number 2 is STR is congruent to TRU by alternate interior angles, AIA. It says all this other stuff, that's what it means. SR is parallel to TU given. Angle SRT is congruent to angle UTR by alternate interior angles. RT is congruent to RT by reflexive property. And the triangles are congruent by angle, side, angle. Okay, I'm going to move this up but not cover it up. Number 6. We've got W and Y are both right angles. W and Y are both right angles. So I've marked that. V and X are congruent. VX and XZ are congruent. WY is the midpoint, so both sides have to be equal. So what is this? I've got side angle, so that can't be. So I look, is it a right angle? Do I have the hypotenuse in the leg? So it's hypotenuse leg. Okay, so I write down the given that W and Y are right triangles. I write down they are right triangles. We have right angles and then we have right triangles. We have the given written down, and then we have WX is congruent to XY by definition of midpoint. So the triangles are congruent by hypotenuse leg. Any questions about this last one before we move on to the vocab? Okay. Do you have no questions because you got it right, or do you have no questions because you're so confused you don't know what to ask?
I think I've just given up on this one.
Okay. Don't give up. We're going to make it easier and easier, I promise. Okay. We're going to start with, I'm going to briefly read out the vocab that we've done so far. I'm just going to read the words, and then we're going to move on to the new ones. I've got postulate with the definition, theorem with the definition. We've already done side. I just want this recorded, so if anybody wants to look at it at home, they can. Side, angle, side. Angle, side, angle. And angle, angle, side. And feel free to freeze the frame if you need to copy it down. We did hypotenuse leg as well yesterday, right? Okay, so now we're going to move on. We've got 5 more, and they're much shorter. We've got reflexive property. So for any segment AB, AB is congruent to AB. For any segment AB, AB is congruent to AB. Okay, vertical angle congruence theorem. Vertical angles are congruent, and there's a picture. See how it shapes an X, and they're congruent. If it was the other way, these are congruent as well. Okay. Definition of angle or segment bisectors. A ray bisector cuts a side or angle in half, so both halves are congruent to each other. I'm going to move it up so we can see definition of a midpoint. So reflexive property is going to be covered up. Definition of a midpoint, a point or line that is in the middle of the line makes each half congruent.
For definition of angle is going to be bisected with 70, right?
Yep. Please write these down, guys. I'm giving you 10 points for doing it. Okay, and finally, guys, there is alternate interior angles. If two parallel lines are cut by a transversal, then the pair of alternate interior angles are congruent. And you do want to draw the pictures next to them, guys. I really do think they will help.